So today we're looking at finding the equation that's joining 2 points. So we've randomly, on a map, on a flat surface, representing whatever we like, have been given 2 points. Going to be given this one and this one. All right? Whatever those 2 points are, we can do all those things we currently have done to it. We can actually find out what the, so if this is 5, -2, and this one is -1, 6, we can find the midpoint, we can find the distance between, but if it's not something we have to find, it's not going to give us credit in the test. We only get credit for the things that actually apply to whatever we've been asked. Okay, so we've got these 2 points. They might be go with the Tawa and Porirua points on a map again. All right, somebody's drawn a map. They've represented these 2 points as Tawa Post Office and McDonald's, whatever. And they're asking you to find all sorts of things about it. Now, why would we want to know the equation of a line? That's a very good point. Mostly it's because we might be using it in some sort of computer program or in a computer to help us to ask the computer to do things with that point. So maybe it's monitor, you know how you get the Uber apps. Maybe you don't. Do you know what Uber apps look like? Yep. And you can watch the taxi driving along. The reason that taxi drives along roads is that they use the GPS to the roads have been represented by equations of lines and things like that inside the program. So all this sort of stuff goes heavily into computer science, but also into a lot of things that are science related. Okay, so we've got these 2 points. We're going to call A 5, -2, and B 6, -1. Now, when we draw a line, what do we need? What do we need to have when we draw a line? We need a gradient. Good. We need a gradient. What else do we need? On Friday we needed what else? A gradient and a point. Yeah. So we've got a gradient and a point. Now today we're actually representing this equation using 2 points. We haven't been given the gradient. But what we're going to do is a bit sneaky really, because finding the gradient between 2 points is one of our pieces of evidence for achieved. We can do the whole lot of this in one move, but we're going to break it down into 2 things. So just as we've done up to now, we're going to label the points, x1, y1, x2, y2, and we're going to start off by just finding the gradient. So m equals, we know what it is, y2 minus y1 over x2 minus x1 equals, so -1 take away -2 over 6 take away 5 is 1 plus -1 plus 2 is 1, 6 minus 5 is 1. The gradient of this line, by fluke, is -1. Where's my negative? Okay, good. We all said that to put those 2 the wrong way around. Well, let's try. So I knew I was wrong then. This is always a good teaching point. I ended up with a positive. That's a negative gradient. It goes this way. Positives go this way. So it's not a positive gradient. I knew I'd done something wrong. So I checked my coordinates and I've written this one down the wrong way around. So now I've got 6 and -1. So I've got 6 minus 2 is 4 over -6. Now I've got a negative gradient. All right? So I'm now pretty sure I'm right. That's -2/3. So once we've got the gradient, we can use the same formula we had the other day, which is the y minus y1 equals mx minus x1. We don't have to use the second point. The second point helped us to find the gradient, but now we just use the gradient that we found and the one of the points. It doesn't actually matter which one, but we just tend to use the first one because that's what the formula says. The x and the y, again, they stay in our formula to represent the axes on the line. So y minus -2, which is +2, equals -2 over 3 x minus 5. Okay, now we've got this nice negative 2/3 gradient. We multiply out the bracket, y plus 2 equals negative 2/3 x. These two multiplied together are going to give a positive, so plus 5 times 2 is 10, and we don't multiply the bottom. All right, now we're going to take that negative 2 and bring it over the other side and subtract it. All right, we're going to get y equals negative 2 over 3x, and 10/3 take away 2. So you can put that in your calculator. 10/3 take away 2 will be plus 4/3. All right, so that is the equation of our line. Want another one?
Yep.
Okay, let's go. So let's just say we didn't have any picture and we've just been told that the base was at negative 100, negative 27, more like coordinates that you actually see on a map, and we're trying to get to the treasure chest, which is at 123.46. All right. I've been using little numbers up till now, but there's nothing stopping the numbers from being big. So here they are. Label them. Start off with x1, y1, x2, y2. First coordinate, second coordinate. Right. Gradient equals y2, 46, take away negative 27 over 123, take away negative 100, equals plus, so it's going to be 73 over 223. Now I can put that in my calculator and make it a beautiful number, but I can leave it like that as well. That is the gradient. Then I want to put it into the equation of the line. Y minus y1 equals mx minus x1. I've got a double negative over here and a positives over there, but that's all right because these negatives will make this positive. Y plus 27, so minus negative 27, equals, now the horrible looking fraction, that's okay, and then x minus plus 100. Multiply out the brackets, y plus 27 equals 73 over 223x, and then 100 times the top line, 7300 over 223 plus, but a minus 27 from that. Now I'm probably going to need my calculator. Could one of you grab yours and calculate for me 7300 over 223, take away 27, please. Anybody? Right, I'm going to do it myself. So I've got 7300 over 223 minus 27 is 1279 over 223. Horrible numbers, but in real life you're more likely to get horrible numbers than nice numbers. Okay?